All right, guys, we are on to our second to last section before the end of the semester. And today we're going to talk about isosceles triangles. So isosceles triangles, this is what one looks like. It's a triangle, so it has three sides. A couple of special things about an isosceles triangle is that it has two congruent sides, and they are called the legs. So these two sides right here, these are called legs. And the side that isn't labeled is called the base, or the side that doesn't have a mark is called the base. Sadly, the base is kind of worthless to us unless we're like just solving to figure out like what the length is. The angle where the legs come together. So if this leg, like think about this as like a popsicle stick. If this popsicle stick and this popsicle stick, if they were to cross or if they were to touch, they would touch here at angle B. This angle B is called, it's called the vertex. And then these other angles here, angle 2 and angle 3, where like your popsicle sticks and the base come together. Like if you were to create a popsicle stick and this is your popsicle stick, this is the base. These are called your base angles. Base angles and your legs are the most important things in an isosceles triangle because if we read down here, if two sides of a triangle are congruent, so if you have two legs that are congruent, then the angles opposite those sides are congruent. So what that means is if you have an isosceles triangle with two congruent sides, the angles opposite, which opposite basically means across from. So if here's my congruent side or the side with the marking, if I draw an arrow across from it, this angle 3 across from this one, and this angle 2 would be congruent. So if I have an isosceles triangle, the angles across from them are congruent. That's what that means. So that would mean like angle 2 is congruent to angle 3. So today you're going to be setting a bunch of stuff equal to each other again, like you did yesterday. Maybe using some algebra, maybe not, just depends. Same thing is true. I'm going to draw this triangle a little different just to throw you off a little bit. If you have two angles congruent, so let's say those two angles are congruent, the sides opposite those angles are congruent. So here's my congruent angles. If I go across from them, think of it this way. This side is going to be congruent to this side. So look for your congruent angles or congruent sides and go across from them, and those two pieces are congruent as well. So you end up having a bunch of equal things. Main thing also to keep in mind for this section is that you do have two equal angles or congruent angles inside, and don't forget that the interior or the inside angles in a triangle add up to 180 because that pops up a lot today. So let's take a look at a couple of examples. Basically, a lot of this is going to be me talking through these. Today might be one of those days where you do need to pause, rewind a couple of times. Because I'm going to, all of these are kind of the same depending on what you're given. So like for number 1, you are given one of the base angles. So if you're given one of the base angles, you're going to do this same exact situation every time. Like for number 2, you're given a vertex angle. So if you're given a base angle or if you're given a vertex angle, you solve them differently, but you're going to solve them the same way every single time if you're given just a base angle or given just a vertex angle. So you just have to kind of make sure you know what you're given. So here's my two congruent sides. So across from my congruent sides, I have my congruent angles. So 68 degrees, and then across from here, an angle J. So L and J are going to be my congruent angles. So if I'm filling this in, the first thing they want is angle J. Well, if angle L is 68 degrees, angle J is also 68 degrees. So we know that that is 68 because it's an isosceles triangle. Then they want angle K. Well, now we're back to, we learned about triangles. We have 2 out of the 3 angles. So we're going to add these 2 together. 68 plus 68, you get 136. All of the angles have to add up to 180. So take 180 minus 136 and you get 44 degrees. And that's it. So if you're given one base angle, you're basically given both. So just be careful with that. Number 2. Now we're given the vertex angle. So the vertex angle is this guy up here. Here's my congruent sides. Across from my congruent sides are my congruent angles. So these two guys right here are exactly the same. So neither one of these are 106, but I can find both of them. I do know that they're the same. So the other thing I know is that all of the angles inside of a triangle add up to 180. So if I take 180 minus 106, I get 74. Now 74 is what is left from the 106 with the total 180. These two add up to 74, but they're both exactly the same. So if they both add up to 74, to find one of them, you're going to take that 74 and divide by 2. And that will give you each of them. So 74 divided by 2 is 37. So that's how you solve for the angles. If that was confusing, I'd highly recommend that you pause it, rewind it, look back at it again. Maybe use this video as you're walking through your assignment today. It may be beneficial. I'm also going to stress to you guys to, if you are still wanting maybe some copies of this, if you're like me, a paper pencil person, stop by room 308 and grab one of these. Number 3 has you solving for sides and angles. So here's your two congruent angles. Across from your congruent angles are your congruent sides. So these two sides are congruent. Congruent angles, congruent sides. First thing it asks for is side YZ, which has 1 marking. Well, that has 12, so those are the same. Then it wants you to find angle Y. They give you both base angles, so you're going to add them together. You know, all of them add up to 180. Add these two together, you get 154. Take 180 minus 154, and you get 26 degrees. Now we're on to the algebra, everyone's favorite. But basically, it's the same exact thing. So that's kind of the nice part, is this stuff does kind of flow. Number 4, here's my congruent sides. Across from my sides, here are my congruent angles. So if I need to solve for x, since they both have the same mark, that means that they are equal to each other. So you're going to set them equal. 5x plus 9 equals 8x minus 30. Use your awesome algebra skills to solve. Move your variables first. I like to keep my variables positive, so I'm going to subtract 5x first. 9 equals 3x minus 30. Add 30. 39 equals 3x, then divide by 3. 39 divided by 3, you get x to equal 13. I feel like almost everything is just equal. This is the same idea, so I'm going to skip that one. Number 6, now we're dealing with sides. Here are my two angles that are congruent. Across from the angles are your congruent sides. You're going to get really sick of me saying that. Across from the equal angles are your equal sides. So these two sides that have the same marking, just like yesterday, you set them equal to each other. 15x plus 7 equals 23x minus 17. Once again, I like to keep my variables positive, so I'm going to subtract 15x. 7 equals 8x minus 17. Add 17. 8x equals 24. Divide by 8. X equals 3. So if any of that was confusing, if you need a little bit more of an explanation, pause it, rewind it, all that fun stuff. The best part about these videos, I'm probably going to say that 20 million times today too. So that's everything if they give you a picture. I do want to go over a couple of what to do if they don't give you a picture, because you have to be a little bit more careful than you were yesterday if they don't give you a picture. So we're going to walk through 8 and 9. So for number 8, in the directions, and we're going to draw the picture and label it as we go. It says in triangle RST. So we're going to draw a triangle, and we have to label it RST. Now, it doesn't matter where you put them. So I'm going to put R, then S, then T. Don't make fun of my triangle. It's not a very good one. It says if RT is congruent to ST. So I'm going to mark that on my picture. RT and ST being congruent. These are sides. So we do RT dash, ST dash. So those are my congruent sides. Now let's just also make another marking. If these are my congruent sides, then we know that these are my congruent angles because they're across from them. So there's the information that we know just from that little bit right there. Now I'm going to label what they give me here. It looks like it has to do with some angles. It says angle R is 9x plus 2, which is with the one arc. Angle S is 13x minus 18, which again is with the one arc. So I'm probably going to set those equal because they both have an arc. And then angle T is 17x plus 1, which he's kind of worthless to us because he doesn't have an arc, poor guy. So it says find x and the measure of each angle. So these two have the same marking, so I'm going to set them equal to each other. 13x minus 18 equals 9x plus 2. Use your awesome algebra skills. Subtract 9x, 4x minus 18 equals 2. Add 18. 4x equals 20. Then divide by 4. 20 divided by 4, you get x to equal 5. Then they want you to find the degree measure of R, S, and T. So to find the measure of R, take the 5 and plug it in. 9 times 5 is 45. 45 plus 2 is 47. So that angle is 47 degrees. Now the cool part about this is once you've solved for this angle and you found it to be 47 without any work, that one's 47 as well because they have the same marking. Then you need to find angle T. So you have a couple of options on how to find angle T. You can take the 5 and plug it in for x, or because it's a triangle, this is 47 and this is 47, you can do 47 plus 47 and then subtract that from 180. I don't care which way you do it, whatever one makes the most sense to you, but you need to end up getting an 86. Yeah, so hopefully that makes sense. Let's take a look at number 9. Number 9 is kind of the same thing, and this will be the last example. It says in triangle DEF, so I'm going to draw my triangle, DEF, angle D is congruent to angle E. So angle D and E get the same marking. Now, because these have the same markings, go across from them and mark your sides. And then it says DE is x plus 4. EF is 4x minus 8. And DF is 7x minus 35. So we need to solve for x and then plug it all back into every single side. So these two sides have the same markings, so set them equal. I'm about to run out of time, so I'm not going to rush, but you're basically going to do the same exact thing for this one as you did here. You're going to use your awesome algebra skills to solve and then plug it back in. So if I don't get to the plug it in part, that is, if it cuts me off, that's what you do. So then you get 3x minus 35 equals negative 8. Add 35. 3x equals 27. Divide by 3. You get x to equal 9. Then you plug it in. So if I plug it in right here for DE, actually, if I plug it in for DE, 9 plus 4 is 13. Plug it in right here. 4 times 9 is 36. 36 minus 8 is 28. And if this side is 28, this side is also 28. Whew! I know that was long. I'm super sorry, but isosceles triangles are things that do come back to, I don't want to say haunt us, but they will come back in the future, and you need to make sure you know what you're doing. Please make sure that you are taking notes, and if you have questions today, don't hesitate to reach out. If not, I will be keeping an eye on your Go Formatives and making sure everyone's good to go. See you on Tuesday.